Hey YouTube, Tired Metalhead Weatherman here. Hopefully you guys are doing well. This video has kind of been put to the wayside a little bit over the last week or so due to a significant severe weather threat that I had been following leading up to the eventual severe weather outbreak that would unfold. Now that we've gotten past that threat, we can kind of go back into business as usual to a point. It's still a very active weather pattern for this time of year, so I'm going to try to keep the momentum on this playlist going as best as I can, but if threatening weather calls, I'm going to try to, of course, cover it on the channel here because we're mainly going to be based off forecast here. That's what this channel's about. Although I do like it, it does seem like some of you guys like being educated about this kind of stuff, so I'm going to do my best. But anyway, I promised on the last video of the installment, which was about tornadoes, and the last one we're going to be talking about damaging straight line winds today. So I will say probably in advance this video might be pretty lengthy, so buckle up here because there's probably going to be a lot of talking on this one, probably a few word fumbles here and there because this is a pretty hefty subject. But anyway, I'm going to paraphrase this as best as I can, so just bear with me here. But to start out, damaging windstorm or damaging straight line winds. They're almost as damaging as tornadoes, for one, and they're actually a lot more common in severe thunderstorms than actual tornadoes. Only a handful of severe thunderstorms even produce tornadoes, but we can more often than not, the setup for damaging winds is a little bit more simplistic. Not by much, but regardless of that, let's go ahead and get into it here. I'm already fumbling my words. So when we look for widespread damaging wind events in particular, there's particularly three types of storm systems that we end up looking at. Really, all of them fall under this umbrella here, the QLCS. If you watch my video forecast in the past, you may have heard me use this term QLCS, which stands for quasi-linear convective system. Here it is. Here is the term right here. I have it abbreviated there. But all these linear type systems all fall under that umbrella. The most common of those terms, most common of the storms that occur under that umbrella is called the squall line. I'm almost certain that anyone who lives east of the Rockies that's watched either my videos or has watched weather at some point, if a severe weather event was going on, has probably heard this term before, at least a couple of times. So, to put it in layman's terms, a squall line is typically a line of thunderstorms that end up forming just out ahead of a cold front normally, sometimes ahead of a strong area of surface convergence. And this line of thunderstorms will have the following. It'll have large hail, occasional tornadoes, and of course damaging straight line winds. It's pretty easy to depict out what a squall line is on radar, and we'll get into the imagery in a minute. But these are very dangerous because these have a much greater likelihood of lasting into any hours of the day, as long as conditions are favorable. And this is also what's going to help me lead into this next part here, the bow echo. So usually how a bow echo starts is we end up getting a squalled line, for example, as is, but dynamics will end up playing out to a point where we end up having a bowed out segment of thunderstorms embedded within the squall line, and usually an axis of enhanced winds will push a part of that storm system out ahead of the main part of the line, and this will be reflected on radar as almost a backwards C shape or a bow. And this is almost indicative of an increased area of damaging straight line winds. And you also have to watch this region because just to the north of that, there's like a little apex that forms, and sometimes you'll even get tornadoes out of that. Again, we're going to show that radar imagery in just a minute. So we're going to briefly touch on the surface patterns for the warm season events and the cold season events, because this can happen. This is very common during the equinoxes, and we tend to get a lot of these also during the summer. So these are definitely something to look out for, definitely very useful information. So when we're looking towards summer events, we're looking at, for the surface pattern in particular, we're usually looking for an east to west frontal boundary, usually a cold front. Sometimes we'll have a lot of strong surface convergence, and you'll see those lines form. And of course, with any severe weather event, we're usually looking for high dew points, high theta E, which is almost similar to Cape values, which is just high dew points, high temperatures. And then surface convergence is pretty much linked to lift and upper level forcing. When we look in the upper levels, you're looking for something along the lines of a straight or anticyclonically curved mid to upper level flow, usually a shortwave trough of some type, usually weak. And then you need a warm, moist air. You need usually warm air advecting from 700 to 850 millibars, and usually weak cold advection in the mid to upper levels of the atmosphere. Of course, again, moisture reaching into the low levels of the atmosphere and dry air can be present towards the mid to upper levels, which usually will increase the damaging wind potential. Then of course we look at we have of course our unstable air masses. Usually pretty high Cape values are needed, and pretty extreme convection as well, because without extreme convection and high Cape values, these storms will become more discrete, which usually leans into a greater tornado threat. And then you're also looking for a lot more directional shear, more so than I would say speed shear in this sense. You kind of want a balance of both when it comes to tornadoes. It's a little bit different for damaging winds. Now let's get into what we would be seeing during this time of year. Given the fact that this is December and we're still dealing with multiple changes within the air masses, as the atmosphere is trying to make its mind whether it wants to be warm or cold over the U.S., this is what we tend to have happening. For cold season late event, bow echoes and quasi-linear events, you usually want a strong progressive low pressure system and associated warm and cold fronts. So we already know where our battle zone is going to be. So usually we'll have a squall line that develops north of a warm front and just ahead of the cold sector. Then you want moderate to strong wind fields throughout the atmosphere, usually between 30 to 60 knots, and common with the upper level jet stream axis aloft. And a little difference between the seasons here. During the summer, the wind fields, you actually want the wind field a little bit stronger in a cold event, in a colder event versus a warm event. And then for the most part, during the cool season, you're not really going to have the same kind of instability that you would get during the warm season. However, Cape values, anything over 2,000 joules per kilogram is more than sufficient enough in either situation. But so long as you have any sort of a strong forcing and vertical shear, usually you can overcome that. Of course, you also have to have some of the other essentials like a layer of dry and most likely potentially cold air, often present in the mid levels of the atmosphere. And really, it's not, other than that, we're not really seeing too much difference here between the warm and cold air setups. Now, there's two types of squall line bow echo type patterns. There's the progressive one, which is a little bit more short, a little bit more condensed, mainly going to be oriented and perpendicular to mean environmental winds. The line bulges a little bit faster. You usually will get more downburst out of this one. And then you get the serial bow echo, which is usually a long, extensive line, usually causing widespread damage. And then you can see a bunch of line echo wave patterns that occur. And these are the ones that also are likely to produce squall line tornadoes, QLCS tornadoes. Most of the time, these tornadoes will be weak, but every once in a while, there have been instances where we've had some strong to violent tornadoes in some of these squall lines and QLCSs. Occasionally, even you'll get an embedded supercell. So here's what the reflectivity characteristics of bow echoes and squall lines look like. So this is a bow echo right here. Note the backward C shape right here. Here's the bow apex. Here is where that wind is starting to surge outward this way, but right up in here. And I mentioned this in the last video with tornado genesis. You always look for little areas where there's little inflow notches. And here's one right here. It's not a super strong inflow notch, but one is definitely there. And as a result, you see that warm air coming in, which will be, in this case, a little section of green here. And this is the section of wind that's rushing out from the thunderstorm itself. And right where those two red and greens touch, that's where we have our rotation and a possible tornado. So let's go ahead and take a look at what these setups look like on the surface maps here. So these must be used really carefully because sometimes these setups look virtually identical to tornadic setups. The thing with these are, with our low pressures, if they're a little bit more progressive, if there's a little bit too much upper level forcing, these or the moisture and temperature fields are not supportive of discrete supercells, we'll get these storms that'll form very close to each other. They'll start to compete with each other, and then eventually they'll congeal into a line of storms. We'll move this to the next page here, and lo and behold, here we are. Here's our bow echo right here. And then we even also have to watch out for our flash flood threat with this line of storms, because it usually has quite a bit of rain lagging behind it. And this is also how we can indicate that the front is nearby, because it'll push all this rain out, and then right behind this, it's going to be cloudier skies, then eventually clearing out, and the temperature will start to drop from that point. So we have two types of MCSs that we look for. And MCS, by the way, stands for mesoscale convective system. This is usually a step below the QLCS type. But here is what we have for the flash flood MCS. Flash flood MCS is pretty common, especially during this time of year and towards the spring. We'll see what's called a gust front with these types of storm systems here. And this will be relatively stationary. But make no mistake about it, these can still produce strong winds in their own right. However, the main threat will be flooding, due to the fact that we will have rain falling over the same area for an extended period of time. Now, when we get to that derecho type look, and there's actually specific criteria that you look for with the derecho. There's a fast-moving gust front, and you can almost see little cloud tops forming out ahead of it, or scud clouds. You see them being pushed away from the leading edge of a storm. That's usually a telltale sign. Another key characteristic with a derecho type MCS will be front to rear flow, and then you'll have inflow to the rear of the storm actually. So there's some key differences there. One thing that you look for in a line of thunderstorms, and I'll show you what a gust front actually looks like in a minute here, but it's going to be a surging gust front. That's usually going to be indicative of strong winds being out ahead of the line. And you'll usually experience this probably before the rainfall hits. Every once in a while, you'll get a stronger wind gust when the rain starts to fall a little bit heavier. But for the most part, the strongest winds are going to be just out ahead of that main line. So before I show you what a gust front is, I'm going to show you this picture again. I showed this in the last video in the series. This is what a discrete supercell looks like. And you can almost kind of see a little bit of a setup of a squall line developing here. This doesn't really quite populate into anything just yet. But one thing I want you to note, this storm has no gust front right now. There's other storms trying to form up around it, but this storm has room to breathe. This has an area where you can get inflow into the storm right here. This is our inflow. This is an inflow notch. And therefore, this storm is able to take that warm air in, curl inward, and you can almost see just based off this hook echo here that this cold air on the backside of the storm wraps around. Thus, we get the hook echo. Thus, we get the famous hook echo signature that we all know. Now, whenever a storm is gusting out, this hook will end up turning the other way actually, and you'll see that backward C shape form, and then this will become a windstorm more so than a tornado. And this right here is what the gust front looks like. When a storm starts to gust out like this, that's a telltale sign that there is damaging winds in some level of the atmosphere. It's questionable whether or not this particular instance made it down to the surface. In all likelihood, it did. But the actual measure of how strong the winds are usually won't be known until the storm actually passes through. But this is always a warning sign right here. When you see a line of storms like this, with this particular image right here, you would almost say it looks a little bit like rain, but it's not. It's not drizzle. That is small water droplets, but mostly wind energy pushing them out away from the storm. And that's usually going to be your warning for potentially strong winds here. Then, of course, towards the apex on the north side here, you always have to look out for the chance of tornado. And you see this other kink here that could have potential tornadic activity here too. So let's go ahead and take a final look at what all of these look like on radar. This is a basic squall line right here. You see little areas where there'll be little kinks there. We'll have to always watch for increased damaging winds and tornado potential with this. And then short-lived convective systems. We discussed that earlier. This is going to be a slower gust front here. A little bit of warm air will make its way in. But for the most part, when you have a long-lived convective system, much more inflow. The gust front moves out just a little bit ahead of that rain curtain. And this storm will basically continue to preserve itself as it travels over particular areas. And then here's a radar image of a bow echo. We just discussed this. And notice how these little line segments will form up. Sometimes these will merge into the bow echo and keep this going a little bit longer. And then a derecho is basically something like a bow echo or a squall line, but it will travel over a long distance here. So there's prerequisites of it, and it's highlighted here. There's a concentrated area of damaging wind reports and or convective wind gusts greater than 50 knots that follows a pattern with a long-lived group of storms. Usually this area is about 250 miles long or more. And within the area, there must be at least 3 reports of damage as severe as what could be indicated by a weak tornado and or wind gusts higher than 75 miles an hour or more. the reports must be sufficiently spread apart enough, about 40 miles at least, to indicate the thunderstorm maintained noteworthy intensity for a sufficient period. So this is also a bit there's also a bit of debate going on with the derechos, but that's just part of weather. Same thing can be said with the F5 or EF5 tornado rating. There were some storms last year which some debated were strong enough to have that F5 rating, but there are some technicalities that go into that. Maybe I'll mention that in a video someday, or depending on how things go, maybe I might do a live stream video or live chat with you guys. We'll see what happens there. But here is a great example of a derecho, and I remember this one actually. This was a derecho that ended up starting up in northwestern Illinois over towards Chicago, and it spread all the way throughout the mid-Atlantic. And there's a radar loop of this as well. So I'm going to go ahead and pick that up right here. So here is the line of storms forming. We see the bow echo form, becomes derecho, and just leaves a lot of mess in its wake. A lot of strong winds out ahead of this line. And this just kept on going. I think this was about maybe close to a 600-mile long event. And if we actually look back at the reports, we had 2 tornado reports, but we had 675 damaging wind reports within a 24-hour period, 35 of which were above 65 knots or 75 miles an hour. It's absolutely insane. Like I said, this tends to happen more so towards the summer, so this is no surprise here. But these derechos are a little bit more rare. You may get 1, sometimes 2 within the course of a year. But for the most part, you're mainly looking for squall lines and bow echoes. That will mainly travel about 70 to 100 miles normally. But that's just about it here. This one was a lengthy one, I'm sure. Probably sitting at 22 minutes. That's not as long as I thought it would be. But anyway, I'm still trying to figure out what's going to be next for the severe weather part of this series. I think we're almost to the end. If there's something more you want me to go over, definitely let me know in the comments. Also, of course, if you liked the video, if you've been liking this playlist, definitely drop a like. Definitely gives me even more motivation to keep doing this, even though I just love doing it, and I'm partially doing this for myself anyway. But also, if you haven't subscribed already, if you find this information useful, if you like the forecast, it doesn't hurt. It doesn't cost anything. It doesn't hurt. Go write it. Just go ahead and hit that subscribe button. And if you don't want to miss a video, hit the bell as well. But anyways, this has been Tired Metalhead Weatherman. I'm going to go to bed because I got to get to work in the morning. You guys take care, and I will see you in the next one. Have a good night.